Okay, welcome to the continuation of lesson 20. Just going to start us off with just a practice of what we were doing last time. So we're trying to find the vertex of a quadratic, and we're given the zeros, and we're given a y-intercept. Okay, and we're asked to find the vertex here. So the first thing that might come to mind here, you're given the two zeros here. So first thought might be with those zeros to find the axis symmetry, and that's not a bad thing to do. So let's start with that. So our axis symmetry will be halfway in between those two zeros. So running through that, 4 plus negative 9 all over 2 gives you negative 5 over 2. Okay, now the only thing with this now is, for the vertex we need both an x value and a y value. And we have the x value here from the axis symmetry, but to find the y value, we need an equation to put the axis symmetry into to solve for the optimal value, the y value of the vertex. We don't have that right now, so we actually have to try and find that equation before we can actually find the vertex. So to find the equation, well, we're given the zeros, so if I'm given the zeros, I should try and create factored form. So if I have a 0 at 4, that's going to create a bracket or a factor of x minus 4. Okay, a 0 at minus 9 creates a bracket or factor of x plus 9. And you might remind yourself, why are these signs switched? Well, remember, the zeros are the values of x that make the entire equation 0. If I put 4 in this bracket here, I get 4 minus 4, which is 0. If I put negative 9 to the second factor, I get negative 9 plus 9 equals 0. So this is how I'm going to start with my factor form, but remember, I always have to find my a value out here, because there's only going to be, so while there's infinitely many quadratics that have these two x-intercepts, 4 and negative 9, there's only one that's also going to have a y-intercept of 8. Okay, and we're actually going to use that y-intercept of 8 to help us find that a value. So if the y-intercept is 8, that means the x value, because it's the y-intercept, will be 0. So we're going to sub that into the equation for x and y and solve for a. So that is going to give me 0 minus 4 and 0 plus 9. So simplifying here, I'm going to get negative 4, positive 9, and a little bit of simplification. Some algebra here to solve will tell me that this is going to be negative 36a on the right-hand side of the equation. Divide both sides of the equation by negative 36. And that's going to give me, once I simplify, negative 2 over 9. Okay, so that's my a value. So that gives me my equation. Okay, and now that I have this, I can actually go and finish finding my vertex. Okay, so I have the x value of my vertex, it's my axis symmetry, it's negative 5 over 2. I can now substitute that into the equation for x, and actually then solve for my y. Okay, so negative 5 over 2 minus 4, and negative 5 over 2 plus 9. And we just need to work through all these fractions. So taking it further, I get negative 13 over 2 here, positive 13 over 2 here. Okay, and then multiply all those together, I'm going to get 169 over 18. Okay, so I put that together with my axis symmetry to get my vertex, and then I'm done. So my vertex is going to be at negative 5 over 2, 169 over 18. Okay, and I'm done. Okay, so again here, it helps when you want to find the vertex. If you have the x value, you need to find the y value. So for that, you're going to need to find an equation. So if you don't have an equation, you have to find that first. Okay, with that in mind, let's try another one here. So here we have a quadratic. It has zeros at negative 5 over 3 and 11 over 2, and it passes through the point 4, negative 8. So a lot like some of the other examples before, we want to find the equation of the quadratic. I'm given the zeros. So your first thought might be to set up an equation like so, where we have y equals some a value that we don't know, to have x plus 5 over 3 and x minus 11 over 2. Okay, and the way that would work If we put negative 5 over 3 in here for x, we get 0 inside the bracket. But 11 over 2 into this, we get 0 for the bracket. However, it's not really proper to have fractions inside your different factors for factored form. So we actually want to try and take a different approach to this. We're not going to want to do this. So to think about this, how we're going to get these factors instead, I just want to give you a side example over here. Let's say I gave you y equals 2 bracket 2x plus 1 and then 3x minus 4. Okay, if you want to find your x-intercepts, what you first do is take each of your factors and set them equal to 0. So you get 2x plus 1 equals 0 and 3x minus 4 equals 0, and solve each of these equations for x. So if you went from this, you'd have 2x equals negative 1 and x equals negative 1 over 2. Okay, here you'd get 3x equals 4 and x equals negative 4 over 3. So you'll see that our x-intercepts were fractions here, just like we have up here in our question, but our original factors had no fractions on them. We had coefficients of the x instead. So it is possible to create factors that have no fractions in them. It's just a matter of how we create them. So you might be able to see a pattern between the final value for the x-intercept and the original factor, and that's great if you do. So you can jump, if that's the case, you can just jump right into stating your factors. However, if you don't see it, that's okay. What we're actually going to do is we can actually start with our x-intercepts and then reverse the process. So here, if I have x equals negative a half, if I reverse what I did here, I multiply by 2 to get 2x equals negative 1, and then add 1 to both sides to get 0 on one side. I get 2x plus 1 equals 0, so I could reverse engineer that bracket. Ditto for here with this one. I could start with x equals negative 4 over 3, multiply both sides of the equation and get 3x equals 4. Bring the 4 over to the other side, so you have 3x minus 4 equals 0 to reverse engineer that factor. We can do the exact same thing with what we have here with negative 5 over 3 and 11 over 2. So let's try that. So if I have an x-intercept of negative 5 over 3, okay, and again, let's reverse the equation so I can have something 0 on one side and everything over on the other side. So I'm going to multiply both sides of the equation by 3 here. So that's going to give me 3x equals negative 5. And then I'm going to add 5 to both sides of the equation to get 3x plus 5 equals 0. So that would have been the original factor I would have had to solve for to get my x-intercept. So this is going to be my factor. Over here I'm going to get 3x plus 5. Okay, for 11 over 2 I'm going to do something similar. I'll start with x equals 11 over 2. Multiply both sides of the equation by 2 to get 2x equals 11. Okay, and bring the 11 over through subtraction to get 2x minus 11 equals 0. Okay, so my original factor up here would have been 2x minus 11. Okay, this is a much more proper looking, there's no fractions inside the factors, and this is what I would expect from you guys, given these zeros, to be able to create the factored form. So my factors are 3x plus 5, 2x minus 11 to start, and I still need to find that a value. Okay, so to find that a value, you can do what we did before. We know the equation passes through the point 4, negative 8, so continuing this on down here, I can sub in that point. Okay, so I'm going to let you try that. Sub in 4 for x, negative 8 for y. So pause it for now, try that out, and push play and you're ready to see the answer. Okay, so you can see my steps right here. Again, I put in, I replace x in the equation with 4, I replace y in the equation with negative 8. I simplified inside the brackets first, so I got 3 times 4 plus 5 to get 17. 2 times 4 minus 11 was negative 3. I multiplied 17 and negative 3 together to get negative 51, and then divided both sides of the equation by negative 51. So I end up with an a value of 8 over 51, which means I get an overall equation up here of y equals 8 over 51, bracket 3x plus 5, bracket 2x minus 11. Okay, so again, this looks a lot more proper than having fractions inside each factor. And again, I would expect you guys, if you have a fractional a 0 or an x-intercept that's a fraction, to create a factor with no fractions in it. Okay, let's do one last example involving a word problem here. So we have a bridge that has a shape of a parabolic arch. It's 184 meters wide at the base. The bridge is going to rise 80 meters in height above the roadway, and we can find, we want to try to find an equation or an algebraic relation for the arch, and we can put it in factored form. Okay, so first thing I'm going to do here is actually just sketch this out. So I have a parabolic arch. Let's say it's right there. Okay, I know it's 184 meters wide at the base. Okay, and I know it's 80 meters high. What I'm actually going to do with this is I'm going to put this on a Cartesian plane. Now, how I orient it in the Cartesian plane is actually up to you. Two main suggestions would be to put the origin here at the left side of the arch and create the Cartesian plane like this, with my y-axis being there and my x-axis being across here. Okay, again, this is flexible, right? You could put the origin over here on the right side, you could put the origin here in the middle if you liked. So it's entirely up to you. Your equation might be slightly different in the end depending on which approach you take, but what you get is going to be equivalent regardless. It's still going to be a representation of the archway. So based on this, once I have this archway on my Cartesian plane, I can start getting some points off of this. So right away from looking at the graph, I can see my two x-intercepts. I've got one here at the origin, and I've got another one over here. It's 184 meters over at x equals 184. Okay, so right away from there, if I want to start building factored form like it says here in the question, I've got my zeros at 0 and 184. So for my factored form, if I let h represent my height up here, and x be my horizontal distance here, h will be some a value I don't know. My zeros, so from 0 I get x minus 0, which obviously will simplify to x on my next line, but just to show that step there, I'll put an x minus 0, and I have x minus 184. Okay, those are my two x-intercepts. I'm just going to simplify this here, because remember, x minus 0 is really meaningless. The minus 0 doesn't change anything. So I'm going to rewrite this as ax times x minus 184. Okay, so we're off to a really good start here trying to create that equation in factored form. However, again, just like before, we got to find that a value. So we need another point that's on this parabola, that's on this archway. So what we can actually use to help us out here to find another point, we can use the fact that at our maximum value here, our highest point, we know we're 80 meters high. Okay, so we know the y value of that point is 80. Okay, and for the x value, well, that's going to be the axis of symmetry. Okay, again, that invisible line that cuts the parabola in half, which we know is going to be halfway between our x-intercepts. So to find our axis, I'll just do it up here. We're going to be halfway in between 0 and 184, so 0 plus 184 over 2, which gives me an x value of 92. Okay, so that's the x value of my vertex, but more importantly, it gives me a point that I can use in my equation down here to solve for my a value. So if I sub in x being 92 and an h value of 80, I can solve for a. So that's what I'm going to do. Okay, so again, my height is going to be 80 meters. Okay, at that point, my x value, my horizontal distance, is going to be 92. So everywhere I see an x, I put in 92. So that gives me 80 a times 92 times negative 92. Okay, a quick multiplication there tells me there's going to be negative 8,464 a. Okay, so again, just to finish this off, I'm going to divide both sides of the equation by 8,464. So I'll have negative 80 over 8,464 being my a value. Okay, which actually reduces down to negative 5 over 529. Okay, so all in all, it's going to give me an equation here that I can use to represent my graph. Okay, so that's it, that's all. So you continue the homework I assigned yesterday. I also asked you to complete this chart. So I'll reveal the answers there so you can check your answers. So continue working through the homework, and then going forward we're going to do a few more word problems and get ready for the end of the unit. Okay, thanks a lot. Cheers.